Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to today's episode. Today I'm joined by several members actually of the team at Oxford Space Systems. Oxford Space Systems is a UK-based manufacturer of deployable antennas and related technologies. And today we're going to talk about the sort of skills and the processes and the technologies that are involved in taking a design of a deployable antenna through the manufacturing life cycle and ultimately into space and operated in space. So this is a really interesting topic because it does involve, as I say, a large number of people at different stages in the process and a number of overlapping areas of skill. And we're going to get into a lot of those today and talk about how this work is carried out at Oxford Space Systems. So I have questions to ask of each member of the team who's joined us on the call today. And rather than give an introduction to all of those now, I'm just going to ask each of them to just say briefly what they do at Oxford Space Systems when they are given the answer to their question. Yeah, without further ado, let's get into the topic of deployable antennas. My first question is to Vince. So Vince, how does a new project at OSS typically get started? Maybe give us an overview of what sort of problems you're looking to solve and how does maybe business development or proposal activity work at the company in order to get these projects initiated?
Yes, sure. My name is Vincent Fro. I'm one of the co-founder of Oxford Space Systems, and I'm also a mechanical system specialist. Yes, so to answer your question, there's a number of ways that an opportunity for a new project can arise. So it could be someone having an idea and then we find some R&D funding to develop that idea, or we could answer to a sort of research proposal from European Space Agency, for example. But in most cases, what happens is there's a prospective customer coming to us, a customer that has an idea for a mission that requires some deployable systems, for example, an antenna. So, for example, they need a large antenna for their system to do the Internet of Things or a synthetic aperture radar mission. And they need this antenna to be deployable to fit on their small satellite platform. So they come to us and they basically with some requirements for the system that they want us to develop. And their question at this point is, is it feasible? How much would it cost? And how long would it take? And that's really the approach they have. So they come to us and they ask those questions. What we do from this point is we look at the requirements that are provided and we assess, is it a system that we've already made? Is it we need to modify a system that we already have, or is it going to be a completely new concept? So we look at this and we do some sort of top-level analysis and concept design to establish a preferred architecture for this product. So we do some sort of initial design, let's say. And then we go back to the customer and we propose our top-level design, and inevitably it's not going to fit exactly their requirements. Usually the requirements they provide initially are quite stringent. And so we start a negotiation with them or a trade-off of requirements where we say, well, what's more important for you? That it's a small mass or that it fits into a small volume, or you're really after the performance and the mass is not an issue? Do you have a timeline that you need to respect to meet a certain launch date? So we sort of discuss those requirements with them and work with them to find the best solution in terms of minimizing the complexity, minimizing the volume, the mass, the stiffness. So we look at all these requirements and work with them to find the best solution that suits their needs. And from this point, once we've agreed some sort of baseline architecture, we put a plan together, a development plan. We establish how many sort of physical models we'll have to build to get to the right solution before we have a flight-ready model. And so we schedule all the activities. And once we've done that, we can put a full proposal together. So we put a proposal that details what sort of architecture we are thinking about, how long it will take, what is going to be the cost. And from that point, there shouldn't be any surprise in terms of the proposal to the customer, because we've worked with them to get to that point. And once that proposal is ready, we submit it to the customer, and then we enter the contract negotiation, and then soon after we can start the project with them.
Right, fantastic. I'm really glad you mentioned the fact that there are trade-offs involved in this. Every supplier I speak to on this podcast and our events, everything emphasizes the importance of understanding the trade-offs in space. The environment is as restrictive as you can possibly imagine, and every project has its own key performance criteria, its own, the non-negotiables, and other parts of it need to be negotiable to fulfill the requirements. Brilliant. So, I mean, as following on from that, the RF analysis, the RF performance of the antenna is obviously of vital importance to the entire application, mission, or service. So, to bay it, my next question: how do you run the RF analysis on a new antenna, and what input from the customer do you require at this stage of the project?
So hello, first of all, this is Beit Barakale from Oxford Space Systems, and I'm an RF engineer. So to answer your question, initially on the RF side of things, we would require a set of inputs, as Vince mentioned, from the customers, including the application that the antenna is going to be designed for and specific RF parameters in order to set up the model. So basically, these parameters do include operational band of frequency, power handling, desired gain, beamwidth, side lobe levels, return loss, and many others like this. So the positioning of the antenna on the spacecraft and the surroundings would be a key on determining the limitations on the size of the antenna. So along the path of the building a new antenna model includes a lot of iterations with the mechanical team as well to work out the best possible functioning version of the antenna. So on the RF side, different approaches can be followed in order to design an antenna model from scratch. And these include theoretical background you should have with research, and also calculations to build up the models and to derive some parameters, as well as there are some useful electromagnetic wave simulators with great user interference as well, which do provide instant characteristics of the model that you design in 2D and 3D patterns, and enables you to evaluate the antenna model in a much faster pace. So for different antennas, we use various software programs to be more computationally effective, because we do have products from hundreds of millimeters up to 5 meters dimensions. So what we do is we consider using multiple software tools on the design and analysis stages to achieve an optimal model within the timeline of the projects, with a confidence of achieving a good correlation between the basically designed and the manufactured antenna.
So just a quick follow. I mean, do the customers you work with, do they typically understand all of the RF parameters that you mentioned, or is there a bit of customer education that's involved in helping them understand the difference between polarization and cross-polarization levels, as an example?
So basically, the customers do have a knowledge about the RF side of things as well. So it's basically, as Vince said, it's like negotiating on these parameters.
Okay, that makes sense. And then obviously you're then at the stage where the actual designing of the new antenna can be discussed. So the next question is to Lucas. How do you go about designing a new antenna, and where does this sort of process begin, based on what we've discussed so far?
Hi, I'm Lucas Batista. I am a design engineer at Oxford Space Systems. Based on the proposal phase and also based on the work that the RF team developed with the customer, we basically care about the two things at the very beginning. So first is the final size of the antenna, which was defined by the RF team together with the customer. And then the second thing that we care about most is the initial size of the antenna. So what's the volume and what's the maximum weight we need to design for? So based on those two parameters, and of course there will be other parameters to be considered on the next phases. So we put together a team to brainstorm to follow the initial architecture. And so we can design all the structures and mechanisms to make it possible, the antenna, to go from the stowed stage to the deployed stage after it was launched. And to do that, we used 3D software like, for example, SolidWorks to design all the parts, put all the parts together, check if everything fits. And also, as Vince said, we also have models and tests during all the way. And we have many iterations with the RF team, because we need to be sure that we will achieve what was agreed between the RF team and the customer, or at least to be as close as possible to what was agreed. Sometimes the trade-offs needs to be done, and so we need to always agree with those things.
Brilliant. And as you mentioned, there's a lot of aspects of the mechanism where such trade-offs could come into play, in order to design the best possible result in terms of the RF performance. So that's really interesting. And my next question, follow-up question really, is to Manisha here. I was wondering, are there any other mechanical aspects that need consideration at this stage?
Hi, I'm Manisha Kushwaha. I'm Senior Mechanical Engineer at Oxford Space Systems. So to answer your question, yes, there are many considerations. Once we have the concept that meets our RF and physical constraint requirement, we still have to carry out assessments to ensure that the hardware is functional, is suitable for launch, and it's in-orbit operational. So to do these, we have various analysis tools which we use to mature the design of the mechanism, the structures, and the thermal side of it. And we end by verifying these by tests.
As a quick follow-up, how long could such analysis and testing take?
Long, I think it depends on the product itself. So for a small product, I think turnaround is very quick because there are less elements that link to one another. But as the project is bigger, as you can see that we have some 3-meter, 5-meter antenna, where it could be a lengthier process.
Yeah, the physical size being so important to the performance of everything. So that's fantastic. Thank you. I think this question back to Vince. So we've gone through the design, the RF analysis, and then the mechanical development and analysis and testing. Once these stages are broadly complete, understanding that, as has been emphasized, this is an iterative process with back and forth with the customer. But once those stages are broadly complete, how do you go about testing the new antenna to prepare for launch? And is there anything further that you would do to make sure that sort of the customer needs and requirements are now met with the system that's been developed so far?
Yes, so as mentioned a few times along the process of the design, we have a few models, some prototypes that we call breadboards, or we have engineering models, depending on the level of resemblance to the flight model. We name those models with different names. But let's say engineering models, for example. So it's a model that is roughly representative of what we to fly, but maybe with a few simplification just to prove the concept, to assess some very specific parameters, and that helps us finish the design in a way. But once the design is finished, we then produce a qualification model. So that's a physical model, which is in all aspects the same as the model we are planning to fly. But the purpose of this model is only to be tested. It's never going to fly, and it's just to verify all the requirements, all the parameters, and go through a test campaign to reassure the customer that the product is going to be ready and it's going to work in space. And because this model is only for the purpose of testing, it's not going to fly, we have the luxury in a way to over-test it in a way. So what we do is we increase the duration of the testing and the levels of the testing to make sure we can qualify the product with a lot of margin. So that's when we do the flight model, we are not, very tight with the margins and things like that. And so the typical test we do is deployment, that's deploy as expected. We do vibration to simulate the launch environment, shock. We put it in vacuum and run some thermal cyclings to see if it, the performance is not affected, or how is it affected by vacuum. And with different temperatures, we do some RF tests to verify antenna performance. So a lot of different tests we do. They are all planned to verify specific parameters and to see the system working as a whole. And so once we've passed that qualification test campaign, we are then ready to produce the flight model. So the final model that is going to be delivered to the customer to be put on the rocket and launched into space. And on this model, what we do is we still need to verify that this model works. But we run what we call an acceptance test campaign, which is very similar to the test campaign we run on the qualification model, but with reduced duration and reduced level of testing, so that we don't over-test the unit so that we don't destroy it before it flies, basically, because that would be very unfortunate. So we just do some sort of reduced testing just to say, yeah, it performs as we expect. It's very similar to the qualification unit, and it's now ready to fly. So that's how we go about it. And it's usually, it might seem like a bit of a heavy process, but it's usually agreed at the bid stage, as mentioned before. During the bid, we go through all this sort of sequence of models and testing that we are going to do on the units, and it's all agreed with the customer in advance and all factored into the development time and cost. So it's all planned out from the start.
Brilliant. Yeah, I think people understand. Well, I hope your customers understand that the nature of deployables are that the testing needs to be as rigorous as possible, simply because of the fact that they move in space.
Yes, absolutely. Yeah, the behavior in vacuum and at different temperature is something that we can predict to some extent, but that always needs to be tested because there's limitation into what we can predict through analysis.
Yeah,
we need always to verify these things.
Yeah, absolutely. And I'm assuming, therefore, the nature of the multi-level testing and the delivery of different models at different stages just means that you get to work really closely with your clients and understand a lot about their business and their needs, because you have to have a lot of back and forth and communication with them.
Yes, absolutely, and they would be part of every test review and things like that, and they have to accept, or they have to review and sort of accept the test results. And if there are any doubts to the performance of any system, then we do extra testing and correlation exercise and things like that to make sure we've covered all angles and that we are happy that the system is performing.
Brilliant. Great, thank you. Well, that's a really good overview. Thanks. And I think an area that I find really interesting in the use of deployable antennas is the materials that are created, that are used to create them, because these are kind of very innovative products, and they're required to be put under a lot of, as you've just mentioned, put under a lot of stresses and strains in terms of both, the RF, the thermal performance, the operation in a vacuum, and this is after obviously surviving launch and then operating for however long they're required in the mission. So the actual materials used, materials that are able to move and redeploy and everything in space is very important. So my next question is therefore to Maiken, who works in this area, I know. And so I'd like to ask about your role in the process on the material side. But I was informed that you actually don't have a background in the space sector and are originally from the fashion industry. So if you could give us an overview of how you ended up working in space, I think that would be fascinating, if you don't mind.
Yes, sure. So my name is Maiken Harold, and I am the knitting technician at OSS. And the reason I came up here is kind of messy, I guess. I studied textile and fashion design back in Denmark. That's where I'm from. But ever since I was a little kid, I always had this little love for science as well. So way before university, I actually used to write essays about the colonization on Mars, and I read way too many science fiction books and stuff. And I always had this small idea that I wanted to be a scientist or engineer or something. But growing up, I had to realize where my strength lay and what I wasn't good at. And I realized I wasn't going to be the next Albert Einstein or Elon Musk or any one of those. So I kept working on more the artistic side of textile design, which was my passion. So I started hand knitting when I was 7 years old. Growing up, I then started on the machine. And when I came to university, I then started teaching digital knitting. And it was this encounter with this big magical machine that I realized knitting could be used for pretty much anything. And that's how I ended up here knitting gold for space.
Right. Fascinating. Bringing some of the famous Danish design thinking to the space sector.
Mm-hmm.
Yeah, absolutely. Brilliant. So could you then explain your role in the process and, in the context of what we've discussed so far as the process of developing the antenna, and why your skills, your particular skills are required?
Yes, sure. So in terms of my skills, when I first applied, I wasn't actually sure how I could be of use here. So I was pretty surprised when my manager actually decided to hire me. excited, of course. But it was after a couple of weeks here and I got settled in and I got to know everything that I actually realized, quote, my own potential, you would say. So working with design, which is my background, I had another way of looking at things. And when I would show people the different knitting architectures that we need for our mesh antenna, they would be like, oh, what's that? Why is that important? And that's where I realized also when you hear Birgit and Vince and everybody talking, everyone's kind of their expert in their field. And that's so important because I wouldn't be able to create an antenna by myself and I wouldn't know what RF was about and everything. So we kind of need each other to figure it out, to make this product. And I think that's why it's such a great idea to hire outside the lines, because you get to learn a lot, but you also get to teach others.
Yeah, absolutely. And I think as the space sector in general, across the world, is opening up, there are opportunities for people with the skills, with the interests, with the potential from outside of the traditional aerospace engineering or whatever it is background, physicists and mathematicians, and there are spaces for you in these companies, and you can bring your skills, you can bring your energy and enthusiasm and ideas, and like you say, a different way of looking at things to these exciting, growing industries. Do people work in the cutting edge of technology on Earth and off Earth, of course? So that's really interesting to hear your story. Thank you very much. That's interesting. So, continuing on the topic of the different sets of skills required to develop the deployable antennas at Oxford Space Systems, we mentioned RF analysis, the mechanical aspects of it, and now knitting of the materials itself used in the antennas. Another area that's fascinating is the use of origami. And this question is directed to Ken. Ken, could you just introduce and explain how and why origami is used in engineering in these systems?
Good afternoon. Hi, this is Ken Kitsu speaking. I am a mechanical engineer, part of the R&D group in Oxford Space Systems. And going back to your question, why origami is used in engineering and more particularly in space engineering, I will start with the later one. So how origami is used in space. When it comes to space structures, a bigger is actually better. The bigger area you have, the more thrust your solar sail can get, the more power your solar panel can collect, the more powerful your antenna can be, or your telescope as well. And somehow all of these large space structures need to be packed into the tip of the rocket, then survive launch. And once they reach their final destination, it can be an orbit around the Earth, around another planet, or even a deep space, they need to unpack, they need to unfold to its deployed shape. And during the last decades, origami has been used to create patterns to fold these structures in a very compact and elegant fashion. So that's how origami is used in space engineering, but also origami is used in other fields. We can find origami in robotics, electronics, even in biomedicine. Origami is recently being used to fold heart stents. So these heart stents need to be very tiny to travel through the blood vessels, and once they get to the destination, which is blocked artery, they need to expand and unblock the artery. And even another application I really find interesting is the use of origami in airbags. Origami is recently been used to fold airbags, so they inflate way faster than conventional ones, so they can, give more chances to the people in the car in a case of an accident.
Right, fascinating, really interesting. Wasn't aware of either of those applications, so that's great. That's really interesting background. And I know we have another origami engineer on the podcast as well, Aloysia. Could you explain how origami concepts are applied specifically to antenna deployment and folding?
Hello, I'm Aloysia Russo. I'm the R&D mechanical engineer. Yes, so for answering to your question, origami is applied in a few products at OSS, and there is a particular project where origami fits very well, since the antenna has a kind of flat surface to be folded and deployed, which is the most standard and understood way of origami, best called rigid origami. In this project, origami has the potential to revolutionize the space imaging technique to allow smaller satellites to use it, since it could be stored in a very small volume.
Interesting. And I guess following on from the conversation with Mike again, how did you guys? This is to both of you, I guess, Ken and Aloysia. How did you decide to study origami engineering in the first place? So did you have an idea that you would use this in the space companies, or?
For my case, I didn't know anything about using origami engineering since 5 years ago or so. So when I was going to do my master's in the United States, I had to choose a research topic, and then I found there was a professor actually doing origami deployable space tractors. So for me, it was fascinating, the idea of combining origami and engineering. Me being half Japanese, I've been introduced to origami since a kid from my family in Japan, but I would never could imagine that origami and engineering could be combined. It's like combining art and engineering. For me, it's fascinating. And the other thing that I really like about this particular field is that it's very recent, and I believe it has lots of things to be yet explored.
Well, when I was a kid, I was playing with paper, doing a strange origami, but I never thought that actually could be somehow an engineering. So yeah, I started to research about origami engineering when I was designing ballistic parachutes. As Ken was mentioning before, like they are quite tricky, this kind of parts to be folded, especially when you have to deal with a large area. So you have to pack a large parachute in this example in a very tiny bag. So I was kind of understanding if there was an efficient way to do so. But later, for my master thesis, I've designed and tested a rigid origami solar panel, which could self-deploy and fold in the moon environment thanks to a robotic manipulator and with a rigid mechanism. And during my previous job experience, I've designed and tested a self-reconfigurable solar sail. But this time, the mechanism was kind of addressing the combination of the solar wind and also called the smart material. And so the more I was researching about this topic, the more I could find interesting applications in space, especially in the space sector, where we always wish to use large structure once in orbit, but then we have a very small volume and mass during the satellite's transportation. So we have to solve this transportation issue, let's say.
Yeah, absolutely. Yeah, as Ken mentioned. Oh, that's great. Thank you. It's very interesting that both of you had a sort of similar experiences in that you were attracted to some different aspect of engineering, and then it's almost as if the link with origami itself kind of, if it's not too poetic, unfolded there for both of you as the more that you got involved, and then you were able to bring those skills into space, into the areas of the space sector that OSS is working in, which is great. Now, to go back to Vince, a lot of the technical aspects of deployable antenna development, and it's very clear that a range of different skill sets, vastly different skill sets, are needed. So my next question is, how do you at OSS go about organizing your teams and ensuring that communication is effective across these disciplines and in these projects? We mentioned how important it is to keep the communication going with your customers, but internally it's also vital because you are working on people are working on different areas.
Yes, indeed, that's a very good question, and communication is of course very important. So the way we organize that OSS is we've got different teams. So we've got product teams, so teams that are sort of focused on a specific type of product. So we've got different product teams, and we've got an R&D team, manufacturing and assembly team. When we start a project, we put together a project team. So we take all the individual people with the skills that are needed to realize the project. And this project team is going to work together along the duration of the project and meet regularly and make sure they exchange ideas and they keep the whole project team updated along the realization of the project. And aside from that, we've got also an operation team and a technical excellence team that are sort of having an oversight on what's happening in the project in terms of management and in terms of technical aspects. So to make sure that what is being done is sort of fed back to the other teams so that, we don't reinvent the wheel every time we do a project, so across project communication and making sure that, if there are bits of technology that are needed that we didn't maybe realize at first, that, they are developed by the R&D department. So we've got a sort of a fairly complex organization in terms of how we run the project. And it's all around making sure the communication within the teams, but also outside of the teams, are maintained at all time. We also have a lot of processes that we implement in terms of making sure that we have consistency in the way we produce documents and the way we take decisions, things like that, so that we make sure that all disciplines are involved in the decision making, and that the documents are clear, always following the same sort of format, so that anyone can very easily navigate through it, through the documents and find the right information, things like that. On the wider OSS organization, we also have other meetings that are organization-wise, and they are quite regular. And some of them are formal, some of them are a bit more informal. But it's all about sharing updates, sharing what's happening in different part of the business, and keeping everybody always updated on what's happening, so that questions can be asked and ideas can be generated and things like that. So indeed, and that's a very good question, the communication is very important, and that's a prime focus on running the company effectively, making sure the communication is free.
It sounds that therefore that means there are opportunities for the people in your company on both, because you're focusing both on product side and on project side, which means you're not sure what could come in next year. So
absolutely, yes. And we do a lot of projects, but eventually what we are trying to do is create products, so that customers can come and ask for a product instead of having a new project. And managing that transition between project and product takes a lot of internal organization.
Just to continue on that train of thought, I mean, this is going to require you to have really good people in OSS to work on these projects, and we've spoken to them today. So in terms of bringing them into the environment, a question for Manisha, I think. What is it that you look for in new people to ensure that they can work well in the environment and on the projects and products that we've discussed today?
Yeah, so as you've seen, that what makes OSS great is the people that we have. And that's why getting the right type of people into our business is very important. So we always obviously look for people who are passionate about space, passionate about what we do, but we also look for people who are aligned with our values, which are respect, integrity, support, efficiency, and effectiveness. To abbreviate that is RISE. We look for people who are innovative, adaptable, able to respond to the changing needs of the business. As Vince had elaborated, we get a lot of requests. So we need to have creative minds in our company so they can, come up with ideas very quickly. We also look for people who are collaborative team players, so can work across the teams. So we have project team, R&D team, manufacturing team, technical excellence team. So we want to make sure that they talk to one another. And we also ensure that we have a diverse team so that we can have innovative ideas and we can solve most complex problems.
Brilliant. And as you mentioned, interestingly, diversity in OSS doesn't mean just in inverted commas, the normal diversity that you would expect. It also means diversity in terms of the industries that people have been based in, origami and fashion, which is a very interesting element of this. So that's great. Thank you. And then just to wrap up finally, guys, it's been a really interesting conversation. I think we've learned, the listeners will have learned a lot about how antennas are developed and what goes into deployable antennas and what goes into carrying forth a project like this. And indeed, on your side, what it takes to work on a project like this and what opportunities this brings. So can I just ask what is next for Oxford Space Systems? What are we, June 2022? What's next for the company, and what are you most excited about seeing in the space industry in general in the years to come? I can ask that of Aloysia, please.
Okay, yes, Oxford Space System is developing and gaining flight heritage for portfolio of innovative deployable antennas that enabled the emergence of application services that are not even yet on the market. The company is now scaling up production capability to facilitate to transition to batch production for satellite constellations, and we are excited about seeing our company to grow over the next few years. In fact, keep an eye on the vacancy page, and to deliver our mission in orbit.
Brilliant. Well, I think that's a great place to wrap up, everybody. Unless I just ask if anybody has any final comments.
Well, I would say thank you for having us. I think it was a great discussion and indeed very great questions you've asked, and hopefully we've provided the right answers.
Yeah, absolutely. Thank you. So, as I've mentioned, I think it was great to learn about what Oxford Space Systems does, how projects are carried out, and how work is performed in the company. To all our listeners out there, if you would like to find out more about Oxford Space Systems, we'll have links to the company pages on satsearch, etc., in the show notes, and also on the vacancies page, because there sounds like there are lots of opportunities at the company for people to work and for people to build on their careers wherever their careers may have originated. And it'll be really interesting to see how the company develops and what happens next. And thank you again to everybody for attending today and for being on this podcast. We really appreciate it. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.